In triangle ABC shown below, angle ABC is 120 degrees. So this one is 120 degrees, and AB is 3, BC is 4. If lines perpendicular to AB at A and BC at C meet at D, then find CD. So this is what we need to find. So what we notice is that the shape ABCD is a quadrilateral, and though there is a triangle ABC and triangle ADC, none of these triangles are right angled. So what we have to do is we have to somehow make a right angle triangle. Okay, so how do we make that triangle, and where do we put it? So if you could extend this line AB, and you could extend this line CD, and you could name it like, I don't know, say we name it X, like XAD would be a right angle triangle. So I drew a better triangle, and this is what I drew. So I use a ruler to do it, otherwise it looks too it doesn't look proper. So if I were to name it as X now, the tip of this triangle is X, and you see triangle XAD is right angled. So what we have done here is we extend AB and DC to meet at point X, and therefore triangle XAD is right angled. And you know that angle ABC is 120 degrees, and that we've been given 3 and 4. And then you see we know this angle, angle CDA would equal 360 degrees, because ABCD is a quadrilateral. So 360 degrees minus 90 plus 90 plus 120. So that is 360 minus 180 plus 120, that is 300, and so that is 60 degrees. So that would be 60 degrees, angle CDA. So once we have that 60 degrees, you see we have a 30, 60, 90 right angle triangle. Now where is the 30 degrees? Of course the 30 degrees is here. So angle AXD would equal 180 minus 90 plus 60, that is 30 degrees. 180 minus 150, 30 degrees. So we got our 30 degrees here. So we know that. So we know, see now what is happening is also there's another right angle triangle that I missed, that is angle BCX. So this is also right angled, and also triangle XBC is right angled. So we've got another right angle. So the advantage of having XBC as a right angle triangle is that we know the length of BC, and BC is 4, so we can apply trigonometric ratios. So we can apply trigonometry. So because what would happen is the XB is the hypotenuse, and then we can say sine 30 is opposite divided by the hypotenuse. So I can say sine 30, what should I say? Sine 30 equals BC out of XB, and that would equal BC is 4XB. I don't know. Sine 30 I know is half, and so XB equals 8. So I can write 8, and therefore AX equals 8 plus 3, that is 11. So I know AX is 11, and I can then find AD, or I can find XD straight away. I'd have to just apply the same sine rule, because sine I can't do because it's the adjacent now. So I'd have to do cos of 30 degree equals XA out of XD. And now cos of 30 degree I think is root 3 out of 2, and XA is 11 out of XD. So XD is, so we have to find CD. I better put the question mark or I'll forget. So XD equals 11 multiplied by 2 out of root 3, 22 out of root 3. Let's leave it as that for the moment, because this is not the final answer. We've just managed to get what XD is, because we have to find CD. So we have to find what XC is. So XC, I know what XC is. XC would be, applying Pythagoras, 8 square minus 4 square. That is 64 minus 16, and that is 8, 5 minus 1, 3, root 38. Did I get it right? Yeah, no, sorry, root 48. So XC is root 48, okay? Now, what I know XD and I know what XC is, therefore CD would be 22 out of root 3 minus root 48. So I can write root 48. I can simplify, isn't it? What is it? Root 48 is 4 times 12 is 48. So 4 times, or 16 times 3 is 48. So 16 times 3, 16, sorry. So 16 times 3 is 48. That would be 4 root 3. So I can write, instead of root 48, 4 root 3, which means I can change all this and simply write minus 4 root 3, and that would equal 22 minus 4 times 3 divided by root 3, and that equals 22 minus 12, that is 10 out of root 3. And now we can rationalize the denominator, so that would make it 10 root 3 out of 3. And what is it? It's just units, you know. We can just say units because we've not been provided with any unit. So we get CD equals 10 root 3 out of 3. And that's the answer, really. Thank you so much for your time. Thank you for watching, and please subscribe to at Hypatia Math 147. Thank you.